Okay, so with this, in this next set of solving equations, what the most important things to realize with this is that you have, in this case, you have two bases that both have a variable as an exponent. So these require a little bit more work to go through and to do. I'm going to give myself a little bit more room as I go through and do this. Now, when I'm going through and starting this, I just have to make a choice. It doesn't matter which choice that I make. I'm looking at this right now. My first base is a 5. My second base is a 4. I have to choose what I want to take the log of both sides. It doesn't matter. The only thing that matters is that whatever base that you take for each side, you must do it to the same thing. So what I'm doing here is I'm going to go ahead and take log base 5 of both sides. Now, absolutely really important that whatever base this is matches this. The other thing that's essential is that both of these arguments are on each side of the equation and there's not any addition or subtraction sign. So inside here, I now have 5 to the x minus 2 power is equal to, over here, this is 4 raised to the 2x plus 3 power. Now, because of the properties of exponents, I take whatever this exponent is and bring it all the way in the front. Keep that in parentheses for right now. So what I have here is x minus 2 times log base 5 of 5. This is the identity property. All of this is equal to 1. And over here, again, make sure you leave this in parentheses. It's 2x plus 3 times log base 5 of 4. Now, as I'm rewriting this, I have x minus 2 on this side is equal to 2x plus 3 times the quantity of that times the log 5 of 4. I have to distribute this and multiply 2x times the log base 5 of 4. Then I go through and take 3 and multiply it times the same thing. So on this side of the equation, it is equal to 2x log base 5 of 4 times 3 log base 5 of 4. Now, just like solving regular equations, I want to get all of my x terms on one side of the equation and everything else on the other side. So the x stays on this side. This x stays here. I am actually going to add 2 to both sides of this equation. So the positive 2 comes here. This term I subtract and move to the other side, so that gives me my minus 2x log 5 base 5 of 4 and my plus 3 log base 5 of 4 comes down. All right, I need a little bit more room here. I'm going to go ahead and pull this up a little bit. Now, the key to solving these is to factor out the GCF, which in this case is my x. I have an x term here and here. So when I factor out this x, I now have x, make sure you leave that as a 1, minus 2 log base 5 of 4 is equal to 2 plus 3 log base 5 of 4. And the last step to getting x all by itself is dividing both sides by the same thing. So this is indeed what x is equal to. All of this is equal to x. Now, if you want to go through and use the change of base formula and get a decimal approximation for x, you can also go through and do that. I strongly recommend getting the TI-36X Pro, which allows you to have a variable base at the bottom of the log. By plugging that in, you go ahead into 4 decimal places. That would be negative 6.3429. It depends on how I ask you the question. If I ask you for the exact answer, I want this answer in the box. If I ask you for an approximate answer, then I would want the answer to 4 decimal places that I have in the blue box. All right, I'm going to go ahead and move this up and try another one that I have on our notes page. So for this one, I'm going to go ahead, just because 10 is my common log, I'm going to make sure that I use this, whoops, let me fix that. I'm going to make sure that I use this as in base 10. So I'm going to go ahead and take the log base 10 of each side of this equation. When I go through and do that, now I go ahead and have log base 10 is understood here of 10 to the 7 minus x is equal to log of 5 to the x plus 1. And again, remember that that base 10 is understood with these questions. I take my exponents for both of these and bring them out front. Remembering when I write them down, I want to go ahead and keep them in parentheses at first. So I have 7 minus x times log of 10 is equal to x plus 1 times log of 5. Again, that base 10 is understood when it is not written. Log base 10 of 10 is my identity, so that is equal to 1. On the left side of the equation, I just have 7 minus x. Over here on the right-hand side of the equation, remember, I've got to distribute this. So after I distribute, I have x times log of 5 plus just the log of 5 here. At this point in time, I want to get all of my variables on one side, and this time and everything else on the other side. Move this up a little bit. So when I go through and do that, I have negative x stayed on this side minus x log of 5 is equal to 7 moves over, and that's going to change signs, plus my log of 5. All right, so I'm going to go ahead and factor this out. I'm going to go ahead and factor out a negative x here. When I do that, then I'm left with 1 plus log base 5 is equal to negative 7 plus log of 5. To solve for x, I divide both sides. So I have negative x is equal to negative 7 plus log of 5 all over 1 plus my log of 5. But again, that x is negative. So I'm going to multiply both sides by a negative 1. and I'm left with x is equal to, I'm going to choose to distribute that negative to the numerator and make that a positive 7 minus log base 5, log 10 of 5, excuse me, and then in the denominator that's going to just stay 1 plus log base 10 of 5. I'm going to leave the last 2 examples on this page for you to finish solving. The answers are presented in the guided notes.